Okay, so let's take up this simple problem involving logarithms. So we have seen that this notation ln is used whenever the logarithm's base is e. So this stands for base e. And in short, we can just write ln, n stands for natural, and the properties, they remain same. So let's start with this equation. So we have ln a plus b over 3. So we are given this equation and we just need to predict what is going to be the value of this sum of these ratios. So we'll start with the equation, and on the right hand side we have this property that ln a plus ln b, that can be written as ln ab, and the 2 remains in the denominator. Or rather, we can push this 2 to the other side. I can pull it here. So we have applied the product rule here, and then we also know that this can go here because we have the power rule. So thereby ln a plus b over 3 whole square, that should be equal to ln ab. And now, since we have isolated the logarithms, so we want to remove these logarithms. So how to do that? We'll just apply base. And we have this property that log of x base b, whole thing raised to power base b, is just x. So we have seen that whenever these bases, they match, they cancel out each other, we are left with only x. So this is the cancellation property we have. And we can invoke it here, and for that we need to know what is the base here. So base here is e, because it's natural log. We'll just use e base both the sides. So let me write this step explicitly, because it's always nice to represent each and everything properly. So now these two things, they will cancel out, and we are left with a plus b over 3 square, or let me put it this way, a plus b square, and I will bring this out. So I have 9 over here, and this side I'm left with ab. And that just means that a square plus b square plus 2ab. ab, I can bring it this side, 9 I can take the other side. So I have a over b, b over a plus 2, this thing should be 9, which just means that a over b plus b over a, that should be 7, which is our required value. We were required to determine this ratio, and that's what we have done over here. So it's a simple problem. We just needed to isolate these logarithms, and that we did here. Once we have isolated logarithms, we can remove them easily by just putting the similar base, the same base that is present here. So here it was e, base was e, so we applied the same base, and then the cancellation happened, and we were left with this expression which just gives us the value. Right, so plain simple, nothing funny going over here. So, right, so that finishes this problem. We'll take up more. Till then, bye-bye.